then 2 times 8 plus 7 times 2. 3 times 8 plus 4 times 2. That settle the first row and the first. This settle the first row and the first column. Now, then the second case, we have 1 times 4 plus 5 times 5. Then we have 2 times 4 plus 2 times 4 plus, the first one we have 1 times 4 plus 5 times 5. Then we have 2 times 4 plus 7 times 5. Then we have 3 times 4 plus 4 times 5. That settles that. Now, to transfer this to the topmost or the upper part of the board, we have 1 times 8 plus 5 times 2. Then we have 2 times 8 plus 7 times 2. Then we have 3 times 8 plus 4 times 2. For the first case. Then the second case, we have 1 times 4 plus 5 times 5. 2 times 4 plus 7 times 5. Then 3 times 4 plus 4 times 5. Then we have 1 times 3 plus 5 times 8. 2 times 3 plus 7 times 8. 3 times 3 plus 4 times 8. Then the last one here, we have 3 times 1 plus 4 times 6. We have 3 times 1 plus 4. 3, this one will definitely be 1 times 1. 1 times 1 plus 5 times 6. Then 2 times 1 plus 7 times 6. 3 times 1 plus 4 times 6. That is what we are going to have. Let's cross-check it again to be sure that we have the right result. 1 times 8 plus 5 times 2, yes. 2 times 8 plus 7 times 2, yes. 3 times 8 plus 4 times 2, that means. Then the second case, 1 times 4 plus 5 times 5, yes. 2 times 4 plus 7 times 5, yes. 3 times 4 plus 4 times 5, yes. Then this 1 times 3 plus 5 times 8, yes. 2 times 3 plus 7 times 8, yes. 3 times 3 plus 4 times 8, yes. Then 1 times 1 plus 5 times 6, yes. 2 times 1 plus 7 times 6, yes. 3 times 1 plus 4 times 6. So that is perfect. Then we'll have 1 times 8, 8, plus 5 times 2, 10. 2 times 8, 16, plus 7 times 2, 14. 3 times 8, 24, plus 4 times 2, 8. Then we'll have 1 times 4, 4, plus 5 times 5, 25. 2 times 4, 8, plus 7 times 5, 35. 3 times 4, 12, plus 4 times 5, 20. 1 times 3, 3, plus 4 times 5 times 8, 40. 2 times 3, 6, plus 7 times 8, 56. 3 times 3, 9, plus 4 times 8, 32. 1 times 1, 1, plus 5 times 6, 30. 2 times 1, 2, plus 7 times 6, 42. 3 times 1, 3, plus 4 times 6, 24. 8 plus 10, 18. 16 plus 14, 30. 24 plus 8, 32. 4 plus 25, 29. 8 plus 35, 43. 12 plus 20, 32. 3 plus 40, 43. 6 plus 56, that is 62. 9 plus 41. 1 plus 30, 31. 2 plus 42, 44. 3 plus 24, 27. So this will be the resulting matrix for A multiplied by B, which results to 3 by 4. 3 by 4, 1, 2, 3. For the row, for the column, 1, 2, 3, 4. So example 3 now. The example 3 is on the board. We have if A is equal to this, find A square. We have to find A square here. Since our A has been given to be 4, 7, 5, 2, then we have to find A square. A square is the same thing as A dot A. That is A multiplied, matrix A multiplied by another matrix. Matrix A multiplied by itself. So you have, then you have 4, 7, 5, 2 multiplying by 4, 7, 5, 2. We must verify whether this matrix is feasible. So we'll have A is 2 by 2 matrix. So A equals to A. 2 by 2 is equals to 2 by 2. So at the end, we are supposed to have a 2 by 2 matrix. So you want to get a 2 by 2 here. It will be done by saying 4 times 4. 4 times 4 plus 7 times 5. Then we have 5 times 4 plus 2 times 5. Then we'll repeat the same for this. 4 times 7 plus 7 times 2. Then we'll have 5 times 7 plus 2 times 2. So that will give us 4 times 4, 16, plus 7 times 5, 35. 5 times 4, 20, plus 2 times 5, 10. 4 times 7, 28, plus 7 times 2, 14. 5 times 5, 35, plus 2 times 2, 4. So at the end, we are going to have 41, 30. This is 42. And this is 39. So this is a 2 by 2 matrix. So that's the answer we are going to get. Then let's talk about transpose, another concept in matrix. We have transpose. A transpose, a matrix is said to be a transpose of the original if the number, if such matrix is interchanged such that the row of the original becomes the column of the new matrix. And that can be justified by saying if A is a matrix, then AT will definitely be the transpose of the original matrix. So in that situation, if A is given as 4, 6, 7, 9, 2, 5, then we can say that the transpose of this will be this row will now be the colon. So that means it will go like this. This is the row, and it will now become the colon. So automatically here, so AT, which is where T is denoted by the transpose. So you have T represent the transpose. So we have 4, 6, which is the row here. It will now be 4, 6 as a colon. 7, 9, which is the row here, will now be 7, 9, which is the colon. 2, 5, which is the row here, will now be 2, 5, which is the colon. So this is the transpose of the original matrix. So that is what is referred to as the transpose. Then we still move further to talk about the identity. Identity, we have two identity of this kind. We have the identity, we have 2 by 2 identity, and we also have 3 by 3 identity. We talk about 2 by 2 identity. I, denoted by I, it is 1, 0, 0, 1. 1, 0, 0, 1 for the 2 by 2 identity. But for the 3 by 3 identity, we have 1, 0, 0, 0, 1, 0, then we have 0, 0, 1. This is 3 by 3 identity. 3 by 3 identity. Now let's talk about another important concept in matrices, and that is the determinant. Determinant of a square matrix, it is the determinant having the same element as those of the matrix, and examples are shown below. Before